Welcome everybody to the SIG Network meeting for Thursday, February 3rd, 2022. Issue triage time. Who has it up? Anybody?
I have it up.
All right.
Good. All right.
Let's go with Tim.
All right. Should be easy today if I can find the right window. Describe. Yes, that's the right one. There are a whopping 4 for us to look at today.
There were 13 earlier. I know
there were. There's
some triage.
Yes, I noticed many people doing triage, so I just filtered those out. Anybody who went through and pinged theirs and asked for whatever original poster feedback, I filtered those out of this list. And I think I closed one that was just long idle. So here's the 4 that I think are left worth talking about. The first one is pretty clearly a bug in the describer for ingress. I left it open here. I actually added the help wanted label, and I'm going to take triage off. I left it open here just to throw out. This seems like should be a relatively easy bug if people are looking for things that they want to, that they can contribute. This is maybe a good starter bug to just go look at the describer and figure out if we can just maybe delete those lines and update the test if it was even tested. Hopefully a small one, easy way for somebody to score a point.
Based on that comment, though, it looked like the behavior was somewhat intentional in the beginning, or have we decided that that is just not useful anymore?
I mean, I looked around and I can't find anywhere that we actually enforced this. It's in some of the implementations, and that's fine. If the describer is true to the resource that's reading from the API, then the describer will show the correct thing if the implementation made that choice. But we don't need to pretend the implementation made the choice when it didn't.
Okay, fair enough. And
this is, seeing Prashant's name on this brings back some memories. That was a long time back, 2015. Feels like forever ago. So I will leave this one open. I accepted the triage on it. Should be a good one for someone who wants to jump in. If you've got someone new in your org or in your orbit that wants a good bug to start on, here's a fun one. Second was a flaky test. This one is clearly a GCP thing. It looks like we leaked a load balancer. Bowie is assigned. I'm not even sure why I didn't just close the window. Bowie's assigned. I think I left it open just to ping Bowie to remind him that he's assigned to this one.
Yep, I'll take a look.
All right. UDP traffic to a single pod behind a cluster IP is black hole when the destination changed.
Yeah, I'm holding on to this one. I'm trying to repro it. That's
okay.
The current status.
Okay. And the last one then was better availability of deployments with replicas equals 1. I suggested that it's actually a dupe of the external and internal traffic policy issues. So I will take the action to mark it as a dupe and close it out. That's it. Fastest triage ever.
All right, on to the agenda then. Let's see. We first have updates from Kaping, APAC working group. Who wants to take that one?
Hey, hi everyone. I'm Rajesh Kaputkar. This is actually my first time joining the SIG Network meeting.
Welcome.
Thank
Welcome.
you. Thank you. I work at VMware and I've contributed to SIG testing before, and off late I've been helping with the Kaping working group. So I've a couple of updates on where we are with Kaping. So I'll probably share my screen and walk you all through it. Are you all able to see some yellow slides?
Yep, looks good.
Yep.
Cool. Okay, so what we did with Kaping was like a bunch of us who happened to be in APAC time zone got together and formed this working group apart from the Kaping main group to work during APAC hours. And the goal was to so this happened somewhere around December last year, and the goal was to get CI working for cupping, focus on a couple of backends like IP tables, IPVS, user space, and there are a bunch of us in this group who are new to stuff. So what we do is we meet every Wednesday at around 7 p.m. IST. That happens to be like 5:30 a.m. PST, and we hack on stuff. Like most recently, we've been like trying to fix test cases, test failures around IP tables, IPVS backends caught in the CI and stuff like that. So over a period of 2 months or so, this is where we are currently, wherein we have got GitHub Actions working for cupping. So thanks to folks like Neha, Friedrich, Anusha, Douglas, they've been super helpful to get these, the hooks around CI to test backends like IP tables and things like that. This basically runs E2E conformance and signet tests as of now. Apart from that, this is also like if someone wants to try out cupping without running E2E tests and things like that, probably should use this script.
Also, big thanks to Antonio for hacking that whole script together, because the initial one was all Sonabui and it was all weird and stuff. So he kind of got us on the right track, and we copied all of his code, and then we got it. Yeah.
Yep, that's right. Thanks for pitching in, Jay. Sorry, I think I missed out including Antonio here. Okay. Apart from like focusing on the backend side of things, we got Windows user space in. It's not yet integrated with the CI yet, but I think we're getting there. From the IPVS and IP tables point of view, we caught a bunch of E2E failures, and then Neha and Anusha, they've been working with Vivek and Hanmant around fixing these issues. Like off late, we have some things around session affinity and things like that. And like these backends still don't have unit tests. So if anyone wants to, start contributing to cupping and see how these backends are written in cupping, I think this is a great opportunity to get started with cupping. Apart from that, sorry, these are the old slides. Yeah, apart from that, on the user space port front, we have there's a PR in flight. We have the changes in, but then there are a couple of E2E tests failing, and we're still trying to fix that. I'm basically helping Jay to get user space in shape. Most recently, Pallavi joined us to help us out. And yeah, also Mikhail introduced this diff store to us in NFT backend. So if we look at the backends, NFT is sort of using a full state model over here, as opposed to how IP tables and all in the current implementation of kubeproxy, how they use service change tracker data structs and things like that. NFT is using something different, wherein they're getting the entire state of the cluster with all the service endpoints and things like that, and using this diff store, which basically happens to be a B tree under the hood. It's trying to get a diff of what all has changed and then write the NF table rules. Jay, feel free to pitch in, because I mean, I'll get the details right here. So this is something new that has been introduced, and yeah, I mean, it's super fun code to go through. So if anyone's also out there, looking to contribute to documentation and things around diff store, like that's also a great opportunity. Apart from that, we are also working on upgrading or move to Go 1.18, and this is pretty much where we are with cupping. So yeah, I mean, this is all I had. If you want to add anything to this, Jay, feel free to go ahead.
Now, what time is it in India right now?
It's almost 4 a.m. now.
Oh shit! Damn.
Thank you so much for coming and telling us about this at an inconvenient time. This is really great to see this update.
Are you going to go to sleep or eat breakfast right now?
I think I've started my day pretty early, so
Okay.
I'm just going to continue now.
Yeah.
Yeah, but
thanks for the
Thanks,
update.
Bridget. Yep, thanks.
All right. Let's see. Next up, FQDN support for network policy.
Hi, yeah. Let me, I have some slides which I can pull up. Can you all see my screen? I'm not sure.
Yep, looks good.
All right, cool. Yeah, so this is something that I think we've been talking about a little bit in the network policy working group on the side. And so wanted to bring this to the overall group and have a discussion on that. The things that I wanted to get into right now was basically get a up down on whether we want to add FQDN support in tree as part of one of our built-in APIs. And potentially get some clarity on which API that might be. We'll have some proposals and we can talk through those. I mean, some discussion of the details of the API spec is obviously inevitable, but I'm hoping that we won't get too rat-holed on that, and we can maybe iterate on that in the KEP and maybe just get some high-level yes/no concerns that we can dig into deeper. So a couple of user stories right off the bat. These are things that I think I've seen, and I shared it with the NetPol working group, and people have seen the same things. The first story is we're targeting application developers in both of these examples. The first one is a pretty standard complaint of people who want to write network policies that target external services. They want to say allow egress to some service, whatever it may be. But managing IP blocks can be tedious, and it's not always obvious which IP block you've configured just by looking at your random IPv4 address. And so the request here is I want to be able to write down an FQDN instead and have my CNI do the resolution. So I can just point you to wikipedia.org and you'll handle the rest for me. I don't need to worry about resolving that. Another story that we've run into is a bit of a more advanced use case. This is for application developers who want to be able to use a wildcard syntax when specifying FQDN. So either they have like a cloud provider, they want to say, hey, star.mycloudprovider, just let me talk to all of my cloud provider APIs, or they have some sort of on-prem hosted services and they want to batch allow those. Just a convenience API that lets you allow list a bunch of things instead of having to enumerate them one by one. And these are the overall stories that we're trying to target here. And so this brings us to the proposal for bringing FQDN in tree. And right now, the ideal proposal would be to extend network policy as it currently stands. There's a couple of benefits to doing this. The first is just from a readability and understandability perspective. Users already know what network policy is and they're already configuring it. So it's a convenient place to come inspect what traffic is allowed to leave your clusters or allowed to leave your pods without having to dig too deep. And the second is that the allow list with implicit deny actually works really well for FQDN because you don't have guarantees on completeness of DNS records and all that stuff. It's good to be able to just say, here's what we know is a good IP. You're allowed to egress there. We can get away without making guarantees about completeness of resolving DNS. And this is a sample of what extending the API would look like. Would be adding a top level field, egress FQDNs as an example. And that lets users specify, alongside the ingress and egress blocks today, specify additional FQDN matches by either name or pattern. And then you have the port specification as well, and we'll do like a cross product type thing. It's a little bit dense, so I have a couple of examples that maybe make it easier to see what's going on. In this case, you're selecting, say, all of your pods in the default namespace, and you're saying, yeah, you can egress to this particular website on port 443 TCP. So it's very similar to the standard network policy. You're just swapping out what would have been an IP block for this FQDN. And another version of this, you can still select pods much as you would in network policy today, and you can specify, a name itself, or you can specify a pattern and have sort of a prefix match expansion. An important point to sort of talk through here is about how we fail close. And so this is something that we talked about for a bit. And what I'm proposing right now is to reuse the policy types field that we'd originally added to help extend with egress, I believe, or ingress rather. But the idea is that we would default, use the defaulting in the API server to add this egress tag to any policies that use the egress FQDNs field. And so if any old CNI, if you haven't updated your CNI, but you try to use this egress FQDNs field, you'll basically get a deny all egress policy. And so we'll be able to use the existing mechanisms within the API to just fail closed and lock down your workload. So it's not great from a user smoothness perspective. You'll realize that your traffic isn't going out, and you'll have to dig into why. But at least it's not a security bug, or it's not a hole where we're now egressing a bunch of traffic that we didn't intend to. So that's the idea around how we'd like to extend the API. There's more details in a doc that we've written. I think I linked it in the meeting notes. I guess the alternatives, or I guess, yeah, just a quick look at where this should be added into the API spec. I did some digging on how the API is defined, and there's a few other places like the network policy peer or the network policy egress rule that are contenders for adding FQDN there, either alongside IP block and pod selector as a peer, or even alongside a list of twos. But in both of those cases, you either end up with undefined behavior or failing open as part of the API spec, neither of which sounds particularly exciting or fun. So I'm proposing a top-level field edition for integrating this into network policy. I did a lot of talking there. I guess I'll open it up for some questions, discussion.
No one else says something, I'll say something. So when you have a star, how do you expect this to be resolved? I mean, do you want it to do pretty much an LS on the name serve which might not respond? How do you expect to get all the layer 3 addresses that maps to the star?
Yeah, great question. So a couple of thoughts that we had is, one, the idea that we were kicking around was adding a core DNS plugin, which would act as maybe like a side channel that once it resolves IPs matching your star, it can send the resolved IP out to your network policy provider so that you're also aware of the resolutions as they're happening. Another option, which is more heavyweight, and is to just put in like an Envoy proxy or something like that. That's intercepting your DNS requests, and then try to do update your allow lists based on that.
Well, how do you know that it's addressed by DNS? Just because you put the policies on, one can still use IPs directly, right?
Yeah,
I mean, I understand what you said, for have the patterns in the policy and have some engine that periodically then finds all the A and quad records, right, that match that pattern, and make those available for the policy, or I mean, I don't know, create new policy with the addresses in.
Because it only allows.
Have two levels of policies where you have one that just has the address block.
Well, so since it's only allows, the thing that we can get away with is we won't allow other traffic to egress here. I think the problem that you'll run into is that if you don't do a DNS resolution from your workload, you won't update the allow listed IPs. And so your traffic would, like if you just tried to hit the IP without doing any DNS lookup, you would not have populated the network policy enforcer. So it would be inconvenient in some sense of, you have to do a DNS lookup before you try to egress to that point.
For layer 7 stuff out of an HTTP, it makes perfect sense, right? But for someone that works at layer 3 or layer 4 level, to say that there needs to be a forced name resolution is, I think, very, very hard to explain.
I mean, I'm open to other opinions. My thought is that if you want to use pure like only IPs, you have IP blocks and you can do that. I figure that if you're using FQDN for ease of use, I feel like that extends equally to when you're writing your application, like just as you want.
It might be two different persons, right?
That's entirely possible. I don't have a good answer there.
I think what you said before, sort of the first one, that where you have something that looks at the policies and produce the set of addresses based on sort of what the patterns in the policies are. I mean, I like that part. I mean, I see that doable and make that list available.
That won't work. We do that in OpenShift. It's terrible.
Yeah, it's like you have a race conditions always, right? And time to live and all this.
Exactly.
Yeah.
Well, not only that, like if you have a DNS pointing to multiple records, what you happen to get may not be the one that when the pod gets it, right? So it's like.
Better mute. 4-year-old decided to.
Yeah. So my first thought when I saw this proposal was the same. I think like implementing it as a transliterator seemed not so bad, but to resolve wildcard, you pretty much have to be in the resolution path, right? Like you have to have some active process there. So that's my big number one worry.
But I think that's a feature, not because, like I said, we have this in OpenShift where we implement it by, looking up the thing and checking the TTL and doing a new DNS lookup anytime the TTL expires and trying to deal with all that. And it never works. Like every customer who's ever used it has filed bugs against it. Like you don't want to do that. You have to intercept DNS. There's no other way to make it.
But
I appreciate the passion in that statement, Dan.
I think that's the right thing. If creating a policy for DNS that, I don't know, right now it's called DNS only, but
the DNS is going SSL SSA. I mean TLS as well, right? So
yeah, but the thing, my question is you shut down all DNS in the cluster and you force the resolution of the pods, because you can force the resolve.conf in the pods. And you force all the pods to resolve in your core DNS, whatever DNS. And this core DNS has a policy. And then you put the rules there.
The problem is that this might be, this is per namespace though, right? So how is core DNS supposed to know? Or are you suggesting that core DNS does some of the logic? Just intercept.
What I'm saying is the only way to filter DNS is in the result.
You don't filter it. You have DNS have a side channel to the network policy implementation. So,
yeah, the thing is, I know this pod cannot resolve to this domain. I will send an error, not an IP.
I don't think the proposal was to not resolve, right? Like maybe I missed that. If I'm not allowed to talk to foobar.com and I resolve foobar.com, should I get an NX domain or should I just get an IP that gets blocked?
But how do you do that? Is, for example, right now all these DNS filtering that you can use in your home, right? I don't remember the umbrella and this one. What they do is just they have a list of DNS and they send you to the to a block IP, because otherwise you run into what that widget say. It's impossible to get rules for the IPs resolved by a domain. I mean, just
the way that I had thought about this before is that the network policy implementation tells core DNS, I need to know if anybody asks for the IP address of github.com. And then whenever anybody does, the core DNS plugin will tell the network policy implementation, okay, somebody asked, and this is the result that I'm about to give them. And then that can update the network policies, and then the pod gets the DNS result, and it goes through.
Wouldn't this like the fact that there's a race condition, when people see lots of like instability while this handshake is happening? I can see like people being like, I resolved DNS immediately, I went to go connect, and oops, I got bounced, and then like I decided to bail out at that point.
So you could delay the DNS response until the network policy plugin has said it's ready. But yes, it is still complicated.
I mean, the other problem is that it doesn't prevent the application inside the container from trying to use its own IP address somewhere out there.
Yeah.
You would have to also make sure that you block any like port 53 or something like that traffic, right?
No, you don't, because this is for allow rules, not for deny rules. So it doesn't matter if they use their own IP addresses. They can't get access to anything extra.
Because they didn't go through the central DNS.
Got
They
it.
didn't get approval.
Yeah. I think everybody talks with the background of how they think the network policy should be implemented. A lot of the discussion, hence that the implementation is IP tables. So at the time of packet arrival to connect to github.com, some IP tables should be there to do the allow. But the idea is not every network policy is implemented using IP tables. Some people have firewalls. There are many ways to do it. A lot of the problems, and they are valid problems, and the race conditions described are because everybody thinks that this is IP tables implementation for network.
We need a synchronization between basically commit operation and that has been synchronized in the distributed system. Yep. That is always
so. The way this works on traditional firewalls, think of F5 kind of firewalls. It's packet interceptors. So at the packet arrival, you know the packet, even if it's TLS, you know where the packet is going. And you can do reverse DNS lookup at that point of time. And okay, is this allowed to, as part of the IPs I have or not? Right, or the part of the DNS names I have or not. And that decision is then cached and then TTL on top of it. And then, but if you're relying on IP tables, then you're not on the data path. And
yeah,
hence the race condition.
Is the semantics being proposed could use a reverse record lookup to enforce, as opposed to a capturing the result of the query?
Many domains don't implement reverse lookup, right?
Understood.
You can get the top domain probably, but
I mean, all this though is kind of in reference to implementations. I know people have doubts that it can be implemented, but I think, I don't know, I'm speaking for Rahul now, but isn't this more just like, is this an API that the community thinks we could utilize? And then we can tackle the, can this be implemented if the community thinks it's an API that's worthwhile sort of question? Just my 2 cents on it.
It's a good way of thinking about it. The only catch here is the wildcard. So without wildcard, you can do sort of pre-fetching and prime the cache with IPs and all of that. With wildcard, it's almost impossible to implement if the destination host does not have reverse lookup.
To add my 2 cents, I think in Entria we actually implemented something, some policy similar to this. And the way we do that is that if a policy selects some pod, we intercept any traffic that's going to that pod from source port 53, and then look at what the DNS they're trying to resolve. And we basically wait until some rule is realized on the data path before we actually pass that packet on back to the original requesting pod, so that we know and no pod will get a response. Will even get a DNS response if that's the FQDN we're actually filtering there. So.
But that's also assuming that everything is UDP and TCP. And now, in 2 years, somebody is going to implement TLS DNS, or I don't know the name.
That's true. That's true. Yeah, that's making a lot of assumptions.
I work with telcos, right? And the telcos have been living on that they can intercept DNS requests and basically sell services based on that they know where the users are going. That is going away. So the whole thing with the deep packet inspection, when we look at 5G, where almost everything is encrypted, becomes useless. I mean, then you have encrypted bit streams that you can look at sort of how they behave to try to identify what it is, but the idea to look inside something is becoming not doable.
This seems good. What you're describing seems good.
Private, I have no problem with it. I mean, we refused to do something for China where they wanted to push basically root record in everywhere so we could intercept all the TCP walls. But so the problem when you start doing that is that you get dependent on snooping, and I don't think that is a good idea. It's for the layer 7 stuff where you have URLs, right? This makes more sense, but for layer 3, layer 4,
I mean, doesn't that point back more towards having core DNS have some part to play here? Because if you can't snoop the traffic, then you need to have the thing that's responding be the thing that is involved in the plane.
Absolutely.
Yeah, but I've seen actually a lot of clusters, actually majority of the cluster I've seen, they do split horizon where anything.cluster.local goes to core DNS, anything that's not cluster.local goes to whatever environment DNS outside the cluster. So there are ways, yeah.
What this is saying to me is, go ahead, Antonio.
No, that's the thing of the API. I mean, if it's feasible for all these DNS implementation to implement that kind of policy in DNS, that's my question.
I mean, at the very least, it seems like the star or part of this proposal needs to be optional per plugin, because it's clear that not that many plugins are going to implement it immediately, and it's hard to get right. Does that make sense?
But the rest of it is hard to get right too. Like, I think we need like super well specified semantics, like before we can say that this is or isn't a good idea.
Yeah, I think the API is good. I honestly think the API needs to progress, and we're gonna have to see the implementation as a separate thing. Just to tell you, to set the tone without intercepting the packet. This thing is entirely moot. I can run a pod first that has DNS mask and then download the records I want and then run my pod and resolve using that DNS mask.
So I'm not concerned. Sorry, I'm not convinced that this belongs inside network policy though. Like why is that better than having a new optional resource that defines this as a different thing?
It'd be network policy v2, and that comes with a lot more of entail.
I mean, this sort of dances on the edge of being L7, right? And network policy has always been L4. So are we saying that network policy is open to L7? Because if we are, then what stops us from adding HTTP rules here?
I think the reason for integrating it with network policy is that you want to be able to say, deny all connections except ones to this DNS address. And so like you want this to interact with the existing default denies.
Tim, to your point, this is still L4. It just, instead of describing the endpoint as an IP, you start describing the endpoint as DNS.
If it was implemented in the DNS, oh, sorry, go ahead, Robert.
It opens sort of. I was going to say the intent is L4, if you will. Like the intent is to guard against IP port combos. It's just the specifier is a little bit leaky in terms of the level.
Okay, I can buy that. I still have the question of, is this better built in than in a separate resource?
I would say, do you request an DNS sec, so you're sure that you talk to the right DNS server that's responsible for this name? And there's a lot of things that opens up when you do name resolution. Do you trust the resolution so no one is hijacking it and so on? It's.
I mean, you could argue that you're sort of already L7 anyways, since you can block things based on namespaces, which are sort of connected to L7 addresses. Like, this is a very weird argument that we're getting into.
I waive my concern about L7-ness of it, because I get that the intention is to do L4 enforcement, but you have to do some L7 trickery to get that information. So I'll waive that concern. But suppose I'm an implementation, right? I could just as easily have a separate resource for this, which I can merge with my other network policy resources because I'm the same implementation. Does that make it clearer that it's A, optional, and B, different? I'm asking, not saying.
I mean, that's effectively what we do with OpenShift right now, but that's because it predates network policy.
And it will make sense if we are thinking about building up a function where the CNI can declare capabilities, and we can assert at the API server level that, oh, the thing that you want is not implemented by the CNI. So yes, it can be something separate only if it makes sense in the future where we can assert the capability. I really don't like the idea of discovery by fire. Like, you can now deploy a thing and then you start using it and you don't know if it will work or not, if the CNI you picked up actually implement these things or not. So I'm kind of inclined to a separate API because it's easier, it's better, it's optional, and a lot of people can say, not gonna do that.
But yeah, I guess, like, what is the driver for putting in the same API? Is there some consistency that's required? Is there some interaction that is necessary?
For discoverability and readability, in that the semantics are very much the same as standard network policy. It's a list of allowed egresses in this case, and users know where to go for that today. You write your network policies that target your workloads, and you say what can leave. If you add a new resource, it just adds a layer of friction of, if I need to look at why is my traffic leaving, or I want to change something, I have to aggregate things manually myself, make an edit to the right resource, and then push that out. It's just a layer of friction, confusion.
Aren't they in that situation anyways, because network policies are implicitly glommed together when they're instantiated, when the implementation.
But now there's a new type.
Yeah, we're just kind of making it trickier.
Although we're already doing admin network policy, so.
Yeah, I was about to say.
I think it's also debuggability. It's really hard to figure out why network policies aren't working with an L7 thing. It's easy because you can't access your thing, but and so it's already confusing. And then Antria and Cilium and everybody else and Calico are already implementing an FQDN, I think, right? I know Antria does, and I think Cilium does, and Casey can tell me if I'm wrong, but
right, but that's an argument to standardize it, but not necessarily put in the one resource.
Well, that's the other point, is that it's really hard to know when things don't work with network policy.
If you have an implementation, it's easy to do because then you do an implementation extension, right? But when you're trying to set a sort of a standard, you have to cover everything. So
two types will make the life of the CNI implementer easier, but will make the user lives way harder. The inverse is also true, right? If we made it a single type, it makes the CNI life a little bit harder, right? But it makes the user's life a lot easier. So I'm not sure I buy
a lot easier.
A lot easier for the user because I can see one policy that describes everything, right? I have either namespace, either FQDNs.
No, because I've already got, I can have multiple network policy resources, and with admin network policy, I'm not even allowed to see those because that might be an information leak. So like, we need better tooling anyway. The ability to inspect a single resource and get a picture of the world is just not true.
Yeah, I think like
self-inflicted, right?
It's also just like, let's say you, like how descriptive is the describe code? Like,
but describe code assumes that I can read it, right? Like, I doubt very much that a change to kubectl describe to go off and read all the other resources at the same time would be accepted. And that still assumes that I could even read the admin network policies, which I probably can't. So like, I think, I forget if it was on this call or on one of the other discussions, but we talked about something like a trace route resource where you create it and have the implementation tell you yes or no, it worked or didn't.
If I could just clarify really quickly, is the concern with making this a part of network policy has to do with how we make it optional? Is that a fair summation of the concerns?
I don't think that's the only concern, at least not on my half. There is the, like, would we predicate this on the ability to self-describe capabilities? That, like, if we did that, then you might not be looking at integrating this until 28, because it would take a while to get that work done, right? And maybe we could pipeline them together, but still it'd be some time. The second part of it, though, is just like, API growth is a problem all around. Network policy is not the best factored API. Is this something that we want to put into that API, or is it better to say, you know, it's a different concept, to put it in a different space, even though it has a lot of overlap? Oh, Bridget raises a great point. We've been talking about this for 25 minutes or something. Do you have a proposal doc that you want to bring to the mailing list, or did you already do that?
I have a proposal doc. I can send that out to the mailing list. I haven't sent that out yet.
I think that's probably the next step. Yeah. Sorry, I don't mean to cut you off, but we do have other items on the agenda.
Yeah, so just one quick. So the difference between this and the normal firewall is, right, is that you have access to one of the endpoints. Typically, you just see the 5-tuple. But for next time.
Here's what I'll do. I'll add another item for this next week, or not next week, but next time, and we can circle back to it. Does that sound good?
That sounds good.
Okay.
Yeah, send it to the mailing list in between, and hopefully we can digest it more before then.
Yep.
Will do. Thanks.
All right, Rob, endpoint slice controller fails to sync.
Hey, yeah, I have a somewhat interesting bug that it involves a series of potentially race conditions. I'm not quite sure yet, but I wanted to raise it in case, because I think there's potential to change behavior here. And I want to make sure that if we changed any of the behavior here, it wouldn't break other things. So right now, what the endpoint slice controller does is when it's running through endpoints and trying to convert them, well, pods, and trying to convert them to endpoints, it looks for a node. And it looks for that node to try and determine what the zone that pod is in. That's great. If it doesn't find that node, it bails out entirely and it triggers another sync. It returns an error. We get into the exponential back off, keeps on syncing, or eventually tails off if we run out of retries. That's great. What I've observed here is in some cases, especially if you have some level of churn, you can run into a scenario where the node just doesn't exist, and therefore the service is never updated. The endpoint slices for that service just become stale as long as we're in that state, which does not feel great. I think we just never, at least from my perspective, I think we just never expected to get into that position where a pod refers to a node that doesn't exist. There are a few real use cases that happens in. The most likely one that I can think of is in garbage collection. So when node lifecycle controller says, hey, I don't see this node anymore, I'm going to get rid of it. If there's still pods attached to that node, the node is gone before the pod garbage collection even starts. So it is a real thing. I've observed in at least one case where this lasted for around 6 minutes, where there were no endpoint slice updates for a service. The alternative that I can think of is either drop endpoints where we can't find a node because something's weird is going on here, but then we risk dropping all endpoints if our node informer is crazy, out of date, whatever. And the other option is just, if we don't have a node, continue on and just don't populate zone. That seems likely like the safest bet, but it means that we're populating endpoint slices in a potentially inconsistent way. It means that, oh, in 99.9% of cases, you can expect to have a zone here, but there might not be. And it is technically an optional field, but I am concerned that there are some things out there that expect it to be present because traditionally it always has been.
Yeah, wouldn't that then just push the throwing away piece to the next person? It's like, oh, well, actually, I really needed the zone, so I'm going to have to throw this away anyways.
Right. So that's it. So if we don't have a zone and someone actually depends on it, or maybe more likely, if we don't have a node, maybe we are in that state where the pod is about to get cleaned up anyways. I don't know. There's probably not enough time to go in depth on this issue. I just wanted to raise it. If you have ideas, thoughts, yeah, Andrew, you had a comment.
So there's like dynamic fixes, which is like, okay, maybe we can make it last shorter. There's also just the case of like making it more robust to, like, there could be a bug or something that just causes one node to become invalid and just kind of get stuck there. And like, should the system be able to get over that, or at least kind of limp along?
For me, the main question is, if we don't have a node, the pod is valid or not?
So there's two potential reasons we don't have a node. One, we legitimately don't have a node. And two, endpoint slice controller has lost connectivity, its node watcher failed, some other connectivity piece failed, and we do have a node, the endpoint slice controller just doesn't know about it.
Yeah, but that's impossible because the connection is the same for the pod and for the node.
I mean, it seems at least possible that one watcher fails and the other one doesn't, or things come out of order. Like, let's say we get the pod ad before we get the node ad. And that seems unlikely, but it could happen.
Yeah, that's true. That's true.
Should we lean on some sort of heuristic of like, it's one node, that's fine, you can just exclude it, versus it's all of them, and hey, we should probably just assume that there's a bug somewhere else in the stack and not exclude them?
That's dangerous.
So is either of the other options.
I'm not convinced that those are the only options. What I've been thinking is, when do we consider a pod is dead?
So in this specific case, what was happening is the VM itself was gone from the cloud provider. Node lifecycle controller cleans up the node, and then pod garbage collector sees, oh, there's no node attached to this pod, let me delete the pod. But each of those steps takes time, and there's a period where the pod is just orphaned.
Well, then the pod is not valid.
Yes, but that's not the only way this can happen. You know, like there are other race conditions that can lead to this where the pod is legitimately valid and we just don't know about the node.
Kubelet failure on the node will give you exactly the situation that Rob described.
Yeah, but let me do the question on the other side is, you can never have a pod. So the pod is always after the node. So the pod, the node for sure has to be before the pod.
Yeah, but the same applies for garbage collection. The node is garbage collected always before the pod is.
Yeah, then we can only have one way this happen.
So do we have a history of why the node garbage collector does not just garbage collect the pods as it deletes the node? Because at this point of time, it knows that these pods are. It seems to me like silly, like, oh, I'm just gonna clean this side of the room where I live. I don't give a damn about the rest of the room, which is everybody else lives in. It sounds silly, right?
No, I agree. I mean, it's two different controllers doing different things in their own isolated worlds, but it'd be nice if they all just did the same thing.
Yeah, but we do that for services and endpoints. We force a delete endpoints when the service is gone from the service's rest path, right? So yeah, I don't think we're gonna have I need to read and think and contemplate on this one. This is a hard one. So
also, I think this would be easier if that was the only potential trigger. Like that's one of the most likely triggers, but there's all these other potential race conditions that could lead to the same condition.
Yeah, but I think that you can never have a pod without having the node first. So this is only one way. That is that then if the node is gone, it's because the pod is going to be gone. I mean, it's impossible that you create a pod and you receive the node creation after the pod was created. Or if it's possible, it has to be something that you.
Someone else deletes it and leaves dangling pointers, and you're screwed, right?
No, the point is, you need to create.
You need to delete the whole cluster of objects at the same time.
Antonio, the absolution in your statement, man, is fantastic. Like, I've seen enough stuff to tell you that this can happen more frequent than what we think. A classic example I'm thinking of is somebody doing in-place upgrade for nodes. Just think somebody over, I'm gonna take this node down. It's node X. I'm gonna take it down for 30 seconds, replat it, repave it, and then go back up again.
Yeah, but
it depends how fast the node garbage collector will work.
Yeah, but that's
maybe
the thing.
Yeah.
The pod is
so
always.
I think, Rob, it sounds like we should probably take this to a doc and kind of sketch out all the different conditions. It sounds fairly complicated.
It does.
Also, we got one item left in the agenda, and I wanted to make sure, Cal, is that something that we want to target?
It's not
that
urgent.
Enhancement today. Okay, never mind.
It's not urgent, but we need to make a decision early in the release cycles because there is dependency on a cap and a dependency on some code. So we just need to make a decision.
Yeah,
I moved that one to next week so that we could finish talking about the thing we're talking about now.
Yeah, since it involved the cap, I just wanted to make sure it wasn't urgent.
But it's solved. It's team approved, then approved, and I talked with the person that reported the issue. They tested it.
This was what I approved. Adds the second IP, but it doesn't make any statement about what if my node was DHCP'd and got entirely new IP addresses.
Okay, then it's about that. Okay, it's not about. Sorry, then I thought that was about the issue.
No, it's not about having another IP. It's about when do we update the IPs.
And also, I mean, just look at V6. That happens all the time.
Yeah, Rob, before we drop off, there's a comment you made, and it's gonna like let a light bulb in my head. Failure in the watchers should be discussed outside the context of this problem. Yeah, we can decode it defensively against failure of the watcher. So let's say you lost connection to the watcher and you're not getting the update and you decide to bail out and restart everything. That's fine. But you can never really make any assumption about the watchers working or not.
Yeah.
That's a fair point. If we separate those out, then yeah.
Because we had a problem, I remember in clusters, kubeproxy was losing connections to the API server. So it wasn't getting the updates. So now what, right? It's a combination of load balancers and keep alives and all that stuff. But yeah,
the problem there is it's a question every watcher has to answer independently. What happens if I stop getting updates wrongly, right? This is a pattern that our internal systems at Google handle in various ways of like, I don't believe that 50% of my cluster disappeared at the same time, so I'm going to ignore this update. There's something else wrong, right?
Every controller needs to make a decision about that and make assumptions.
Yeah, and I think even ignoring the watcher issue, there's this issue of consistency. Like, let's say a pod just sticks around with like a bad node name, like you should probably like toss it at some point or just ignore it. It's like there could be these like data consistency issues that just because of a bug or something that if you took a strict view of it, like absolutely not, like I'm not going to proceed because this is inconsistent, on some level that may end up resulting in some kind of outage because you just like the controller couldn't.
Yeah, I agree. That's a great point, Boy, because node name is actually user settable, right? It's a request for scheduling. So if I want to cause havoc on you, would this be a good one for the clustered podcast? I create a pod that has a wrong node name and watch all your endpoints disappear.
Yeah.
Huh.
Yeah, and now we have on record an attack vector for everybody to go and try.
I'm assuming that doesn't work, but I don't know. I didn't try it.
I mean, the attack vector has to be in your own namespace, so at least it's pretty well bounded, right?
Yeah. Yeah.
Yeah, I have
Rob,
a
get a CVE number.
What's that? Oh, yeah.
Get a CVE number just for you.
Rob already owns a couple, so.
Yeah, it's fair. Yeah, I have a pretty detailed description in the bug itself or an issue. So please, if you have time, chime in there with thoughts, perspective, different approaches. My biggest concern is I don't want to break something else in the process of trying to fix this, which it seems likely could be the result. So anyway, I know we're at time, so I don't want to take too much more, but yeah, thank you.
Thank you. Thank you, folks.
All right, thanks.
Thanks.
Bye.
Happy Cap Freeze Day.
Yeah,
thanks,
and
everyone.
I'll say it again. Anybody who hasn't, if you have a CAP and you need it to be approved before, and we've got like an hour or something, right? And it hasn't been approved yet or LGTM'd yet, please ping me. Let me know on Slack ASAP. I think I've got them all, but if I happen to have missed yours, please let me know. Thanks all.
Bye.